everyone. I'm Advaita.
And my name is Aarav.
And we are from Delhi Public School, Bangalore North.
This video is comprised into 3 sections. 1. The introduction. 2. A quick project demonstration. And 3. The appendixes.
The appendices includes brainstorming, analyzing requirements,
prototyping, developing the product, and finally testing. Without further ado, let's move on to the introduction. Today, we are going to show you a science project that we made called the Automated Controlled Car Parking System. This is our approach to create a car parking system that is completely automated using computers.
This project demonstrates how we can fully automate a car parking system using sensors and motors controlled by software code written in Arduino.
Let's move on to the project demonstration in the next part. Hey guys, this is the final product of the car parking system. It is primarily made out of waste materials. For simplicity, we only have 3 car parking spaces. As you can see, it says the number of car spaces left is only 3. Just to confirm, we can see that all car spaces are free, meaning no cars are there. When a car comes in, the sensor detects the car and the gate opens. When the sensor detects that the car goes in, the gate closes.
Now the car can park in any space where the red light is off, which shows that the place is unoccupied. When the car parks, the red light turns on to show that that space is occupied.
When a second car comes in, the sensor detects the car and the LCD displays update. Now, since the gate is open, the car may enter and find another parking spot.
Now you can see that these 2 car parking spaces, the light is off, so the car can park in any of these spaces. When the car parks, the LED light will turn on. As you can see, all these spaces are occupied and all the LED lights are on. There's a message which says, "No more car spaces left." If a driver comes and ignores the message will change and the gate will not open, resulting in the driver to come back. Now I'll be showcasing a car exit scenario. As you can see, the car park is full and the LCD display says no car spaces left. When this car exits the car parking space, the light turns off and then the sensor detects the car and the motor opens up the gate and the car can now exit. And the LCD display changes.
Now, I shall be demonstrating an edge case scenario, a hypothetical scenario that most likely won't happen, but I'll just show it to you. Let's say a transformer hops inside the car park and tries to steal from some sort of imaginary mall. Now, when they want to leave, let's say they try and get through the gate. As you can see, there are no spaces left, so it shows number of car spaces left is 3. Now, if this car were to try and leave, it won't let it leave and will show a message called the cops. This is because there are no spaces left and it's as if a new car just teleported in and is trying to leave. This is because all the spaces are empty. So how can somebody exit if there's no car to begin with?
Now I'll be taking you into a deep dive into our project. First, we've used waste materials. We got the styrofoam or thermocol from our neighbor's sheds, the cardboard from an old TV box, and the gift wrapping paper from old presents given by our friends. Over to my brother.
Now, looking at the technical side of things, we used an LCD display, which is probably on the more expensive side of things. We have used 5 sensors in this project, 3 for the parking lot and 2 for each of the gates. In the parking lot, the sensors there are used to detect if a car is parked or if a car is not parked. As you can see, we have 1 sensor here for this parking lot, 1 sensor here for that parking lot, and another hidden sensor on the other side for that one. There are also 2 sensors used for the entrance and exit gates. These sensors are used to see if a car is entering or exiting, respectively. The sensors' locations are here for the exit gate and here for the entrance gate. And over here is the hidden sensor that I was talking about earlier. We have also used two motors to control the actual gate. This allows for a car to enter or exit into the parking lot. The motors are here and one on the other side for the entrance, over here. One of the issues that we faced was that the gate was constantly hitting off the styrofoam. In order to fix this, we cut out a small hole over here so that the gate remains undisturbed. Just behind the LCD display, you can find the Arduino. This is the computer of the entire project. The Arduino connects the motors, sensors, an LCD display, and even other electronic items connected to it using jumper wires. We have also used a breadboard to make this connection a bit easier.
Now let me bring you into the internal system of the LED light. As you can see, over here is a breadboard, and over there is an Arduino, which stores all the code of the sensors and LED lights in the parking lot. The sensors are here, here, and one on the other side. The LED lights are here, here, and here. Now going on to the final section, let's start with the brainstorming. We were very excited when we heard about a school project in which we could solve a real-world problem. We both started brainstorming a bunch of ideas of real-world problems. We finally decided on one that was really frustrating for people. When people would go to busy parking lots, they would roam around for hours searching for a parking lot and eventually may not even find a parking spot. Therefore, we have developed an automated control car parking system which solves this real-world problem. Now, let's begin with analyzing requirements. First, we have the automated control car parking system. Then we split it into three parts: the entrance, the car parking, and the exit. Then we have to break it down furthermore. In the entrance, first we have three case scenarios. The first case scenario is when a car comes and they look at the sign and it says the parking is full. Then the car leaves and doesn't even come in. The second case scenario is when a car comes and looks at the sign and which says that the parking is full, and they still try to enter. The gate will not open. The third case scenario is when a car comes and there is space left in the parking lot and the gate opens. Now, moving on to the car parking system. Next is the actual car parking system. There are three case scenarios. The first scenario is when a car comes and it doesn't even park and leaves the parking lot. The second case scenario is when a car comes, parks, and the LED light turns on. The third scenario is when a car leaves the parking space and the light turns off. Now let's go on to the exit case scenarios. Here there are only two scenarios. One, when a car doesn't park and exits straight away. The second scenario is when a car exits normally and the gate opens. Now let's move on to the technical requirements. The technical requirements are lots of wires, 2 Arduino Unos, 2 motors, a bunch of sensors, and the software code that me and my brother wrote in Arduino code.
Now that the requirements phase was over, the prototyping phase was now in action. Instead of instantly using 5 sensors, 5 motors to make everything difficult, we decided to start small, only using 1 sensor. First, we tested out if the sensor worked, which it did, and then we added in a motor to create the gates. Using the combination of both motor and sensor, we created a simple prototype of the entrance gate of the car parking system. After that, we added another pair of entrance and exit gates to complete the exit entrance pair. To finally complete this pair, we had to add the LCD display, which we tested and then finally integrated to create a simple prototype of exiting and entering the car parking system. Even after that, the work was not done because when a car were to park, the light should also show up. So we started small, used one sensor, one light, and after that worked, we added in 2 and then 3. Through this method, we created a simple prototype for parking a car and entering and exiting a car. Instead of throwing away the prototype, we reused it and enhanced it into the working product. Now that the main project was almost finished, we moved on to one of the most difficult and painful steps, testing and debugging. Some of the issues that we found were that the LCD display didn't receive enough power and it was going dim. To solve this, we decided to connect the Arduino to the mains. Now it was connected to the mains, both LCD and motor were able to have sufficient power supply. Another issue was that the LCD was showing random text. In order to solve this, we had to change a bit of code, but eventually it was solved. And the final issue was that all the ports were not able to fit into one Arduino. To solve this, we separated the project into 2 separate parts and coded each of them in 2 separate Arduinos. Alright guys, that was our entire project.
Thank you so much for watching.
See you soon. Bye bye.